Hello everyone. This is a BPT by Chiranjeev Matkar and Atchyut Sharma from the Civil Branch Department on the topic electric industry and how to solve its pollution problems. Let's dive into it. Let's go back to 1752 where Franklin conducted his famous kite experiment in order to show that lightning was electricity. He flew a kite during a thunderstorm with a metal key tied to the kite string. Just as he thought, electricity from the storm clouds transferred to the kite and electricity flowed down the string and gave him a shock. He's lucky that he didn't get hurt, but he didn't mind the shock since it proved his idea. Let's see the importance of electricity. Electricity is an essential part of modern life and it helps us in many different ways. We use electricity for lighting, heating, cooling, refrigeration, for medical purposes, and for operating appliances, electronics, computers, public transportation systems, and much more. We cannot imagine a day where we do not have electricity. Electricity lives with us every moment of time. But first, let's see what is electric power. Electric power systems consist of generation plants of different energy sources, transmission networks, and distribution lines. Each of these components can have environmental impacts at multiple stages of their development and use, including in their construction, during the generation of electricity, and in their decommissioning and disposal. These impacts can be split into operational impacts, fuel sourcing, global atmospheric and localized pollution, and construction impacts, manufacturing, installation, decommissioning, and disposal. All forms of electricity generation have some form of environmental impact. This is a summary of the table of electric power generation. As you can see, we have taken three countries, India, Japan, and USA, where there is shown the percentage capacity of how much they use, what resources they use to produce electric power. That includes coal, oil, gas, nuclear, hydro, and other powers. But electricity generation always brings with it environmental issues. Now let's see some environmental issues in coal-based power generation. Coal-based power generation often produces first, air pollution. High particulate matter emission levels due to the burning of inferior grade coal, which leads to the generation of large quantity of fly ash. Emissions of SO, NOx, and greenhouse gases are also a matter of concern. Second up is water pollution, mainly caused by the effluent discharge from ash ponds, condenser cooling tower, DM plant, and boiler blowdown. Third one is the noise pollution, high noise levels due to the release of high pressure steam and running of fans and motors. And last but not the least, land degradation. About 100 million tons of fly ash is generated by the use of coal for energy production. The disposal of such a large quantity of fly ash has occupied thousands of hectares of land, which includes agricultural and forest land too. Now let's see the pollution load from thermal power plant. Here is the amount of pollutants and emission in tons per day causes for CO, particulate matter, SO2, and NO. This is a graph showing emission estimates for share of suspended particulate matter load tons per day by different categories of industries with control devices installed. Total load being 5365 tons per day. As you can see here, thermal power plant has a lead in the emission estimates. Next up graph is the share of sulfur dioxide load tons per day by different categories of industries. Total load being 3715 tons per day. Here too, thermal power plants has the lead in the race. Now let's see the stack height requirements. For the proper dispersion of SO2 emission from thermal power plant, stack height criteria have been adopted in country. However, for larger capacities boilers, 500 megawatts and above, space provision for installing flue gas desulfurization method has been recommended. Now let's see some of the hazards produced due to coal-based generation of electricity. A fundamental issue regarding centralized generation and the current electrical generation methods in use today is the significant negative environmental effects that many of the generation processes have. Processes such as coal and gas not only release carbon dioxide as they combust, but their extraction from the ground also impacts the environment. Open pit coal mines use large areas of land to extract coal and limit the potential for productive land use after the excavation. Natural gas extraction releases large amounts of methane into the atmosphere when extracted from the ground, greatly increase global greenhouse gases. Per unit of electricity generated, coal and gas fired life cycle greenhouse gas emissions are almost always at least 10 times that of the other generation methods. Although nuclear power plants do not release carbon dioxide through electricity generation, there are significant risks associated with nuclear waste and safety concerns associated with the use of nuclear resources. Let's not forget the fear of nuclear power stems from large-scale catastrophes such as Chernobyl and Fukushima Daiichi nuclear disasters. Both tragedies led to significant casualties and the radioactive contamination of large areas. We have talked enough of the hazards produced by coal-based power generation. Let's talk about the solutions. Some of the solutions being solar power and hydropower. Solar energy is a great renewable resource for producing electricity from the sunlight falling on the receiver panels. We nowadays see solar panels installed on every terrace of every house to produce electricity in a more environmentally friendly way. The next step is hydropower. Hydropower energy is used as a renewable resource by using the potential energy of running water. Falling water on turbines produces electricity with the help of a generator. Next up is flue gas desulfurization. Flue gas desulfurization, or FGD, is a set of technologies used to remove sulfur dioxide (SO2) from exhaust flue gases of fossil fuel power plants and from the emissions of other sulfur oxide emitting processes. Since stringent environmental regulations limiting SO2 emissions have been enacted in many countries, SO2 is being removed from flue gases by a variety of methods. Common methods being wet scrubbing, spray dry, wet sulfuric acid process, and S-NOx flue gas desulfurization. The next up is the electrostatic precipitator. An electrostatic precipitator is defined as a filtration device that is used to remove fine particles like smoke and fine dust from the flowing gas. It is commonly used device for air pollution control. They are used in industries like steel plants, thermal energy plants. In 1907, chemistry professor Frederick Gardner Cottrell patented the first electrostatic precipitator used to collect sulfuric acid mist and lead oxide fumes emitted from various acid making and smelting activities. The next up is Clean Coal Technologies, or CCTS. Clean coal technologies are a new generation of advanced coal utilization processes that are designed to enhance both the efficiency and the environmental acceptability of coal extraction, preparation, and use. This is the need for adoption of CCTS. To meet the increasing demand for power with minimal environmental impact for sustainable development, the adoption of clean coal technologies with enhanced power plant efficiency, fuel switching, use of washed coal, efficient pollution control systems, and proper byproduct and waste handling and utilization is necessary. Pre-combustion technologies, ash, sulfur, and other impurities can be reduced from the coal before it is burned. Combustion technologies, the generation of emissions of SO, NOx, and CO2 can be minimized by adopting improved combustion technologies. Last, post-combustion technologies, end of pipe treatment, installation of pollution control equipment such as ESP, DENO, and DESO systems. This has been the solutions for the electric power generation problems that are undertaken in the electricity generation. We would like to thank you for your attention, and this has been the Convergence Thinkers. Thank you so much.